Our quest system is effectively functional. The only thing that we need to be able to do is to be able to carry data between levels, because maybe you want to pick up a quest in one area and then actually do part of it in another area. Maybe even you want to make quests that need to be completed in a couple of different areas together. That can be a little bit more complicated. And of course, we just want to be able to, in general, save our progress with our quests. So today we're going to go over a save system that will allow us to do all of that. And to get started, I'm going to do this in the game instance. If you're following along in something like C++, you might want to make a game instance subsystem instead, because that way you don't have to overwrite the game instance itself and it doesn't cause like conflict with other systems you might have. But for the most part, our game instance should be fine. So let's make a game instance. We'll call that something like quest GI for game instance. I'm going to open that up and we're going to go into the project settings real quick, and in there find the game instance and change it to our quest game instance. Before we actually do any programming in there though, we're going to go back into Blueprint classes and we'll make a save game as well. And this is going to be our quest save. Let's open that up too. And in here, we're going to make two sets of variables. First and foremost is going to be the completed quests. These are just the quests that are entirely completed and we don't need to worry about saving any like minute progress on. It's just a string that's going to tell us, hey, this quest ID has been completed. If you find the quest with this ID, just mark it as being finished. So that's pretty straightforward. That's the reason that we're giving quests individual IDs, so that we can easily identify them by that ID. Then we're going to go into Blueprint and then into structures, and we'll make a quest save data structure. Let's open that up. And in there, we're going to put the quest ID so that we know what we're talking about. So this is just going to be the string. And then we're going to keep track of the progress of the quest itself in a map. So it'll be a string map with values of floats. So this is going to take in our quest IDs for comparison reasons, and then it's going to check the progress on each individual objective within that quest and store its progression value. So the 0 to 1 value, maybe sometimes more than 0 to 1, we'll get to that. That shows us how much of a certain quest has been completed. And once we've made that, we can go back into our save object and we can make our active quests. And that's of course then going to be an array of type quest save data, the struct that we just made. And you'll be able to see, just as an example here, if I make one, it gives us a quest ID, and then the progress is a map of strings and values. So that's a lot of object setup, but now we can get into the fun part, and that is making a whole lot of functions. So let's go into our quest game instance and start by setting up a event initialize. Whenever we initialize, we want to create a save game object immediately for our quest save. What we're going to be doing is we're going to keep a copy of the save game object in memory at all times, so that we can dynamically pull information from it and write information to it. And then when we either save or load, we just use that version in memory to write to disk or read from disk into that thing. That way we don't have to make a gigantic function sometime down the line when we want to save a bunch of information. We can just, whenever information changes, we send it through to this object, and when we then actually want to save it, we already have the most up-to-date information in the object and we only need to write it to disk. So let's promote that to a variable, and that will be our quest save. Let's make the saving and loading functions for it first, because they're very simple. It's actually going to be as simple as making a custom event, save quest data. And you won't believe how simple this is. This is just save game to slots. And since we already will have an object that has up-to-date information, all we need to do is get our save game object that we created here, and we're going to be continuously populating with new information during the gameplay, and save it to whatever slot that we want to save it to, which is going to be an input parameter for this event. And that's all there is to it. We don't need to set a bunch of values at the moment of saving, because we're constantly doing that during the gameplay. And then we'll make a custom event, which will be load quest data. That's going to check if a save game with a certain slot name exists. And if it does, it's going to load that game from slots. with, of course, that name. We then cast that to the quest save that we just created. And with the quest save, we're just going to set the reference that we create up here to whatever we just loaded in from our slots instead. So we'll override every data about it. So these are two quick and easy functions that you're going to want to have anyway. Now we need to write all the functionality that allows us to update the information in this object dynamically, constantly for these two functions to actually do anything. So let's get started with that. And the first one of which is going to be a custom event, which I will call update quest data. So this is going to be an event that just updates all the quest data from your current level into the current quest object. And the first part of that is actually going to be fairly easy. We just get the quest save, and then we also go into the input parameters for the event, and we make a quest component, which of course is going to be of type quest component object reference, and that is just going to get the finished quests. We're going to get the keys out of that, and in our save object, we're just going to set the completed quests to those keys, because we already have this map that contains all of the IDs of all the quests that we have finished, so we can just directly set that. It's just as easy as that. Now, the next bit is going to be slightly less easy, because we can't simply override the map for the active quests with whatever we have at that time, because the map of quests that exists that are active in your quest component will only be the quests that are in the level that you're in at that given time. So instead, what we need to do is we need to take all those, check if they already exist in our save data. If so, overwrite them. And if not, we need to append them into that list, which is just a bit more tricky than simply doing a quick override like this. So for that, let's go into the quest components, because we need to get the active quest data out of this. So we make a function, get active quest data. And this is relatively straightforward, all things considered, because we can just get the active quests, we get the keys out of that, and we for each loop over those keys. Make sure everything is hooked up. Then for every one of those keys, we're going to find the corresponding object, which is always going to be valid because we're getting it from these keys. And there we need to get the base quest to give us the progress on its objectives. So let's open up our base quest right over here and add in a function for that. So get completion objective progress, maybe something slightly more descriptive in a better way, but for now, that'll do. We get our objectives, which is our main objective collection, and from that, we get the completed objectives. We kind of misnamed this. As the series has gone on, I've realized that things that we set up in the beginning, in the very first video, to do with the string arrays are going to need to be converted to the maps, but we'll worry about that in one moment. Because in the end, we're going to be returning just a single piece of quest data. Make an output of type quest save data, and we'll just call that quest data or something like that. So now we need to go into the get completed objectives function, because at the moment that is returning just an array of strings, and that is going to need to change. So instead of returning an array of strings, this is going to return a map of strings and floats, which actually simplifies some of this quite a bit, because instead of doing this make array and this is complete, what we're actually going to do is we're going to just have one single return node that is going to be making a map. And the map that it's going to make has one entry, which is the key with the objective, and then the get completion progress. And we're going to be saving the unclamped version, because if we go over the amount that we're supposed to get of something, we actually want to be able to save that progress, of course, because that can mean that we get a better reward. If we want to be overriding the get completed objectives in the objective collection, because here we're going to need to change the implementation a little bit as well. We get the sub-objectives and we for each loop over them, of course, as we so often do. And then for each one of the sub-objectives, we're going to get the completed objectives, which is the same function that we're working in right now. Maybe changing the name of this function would make a little bit of sense, but for now I don't really care enough. We'll get the keys out of that. And then we for each loop over each one of those. Then the return node, we can right click on, promote it to a local variable. I'm just going to keep this as new local var for the time being, because I really don't care about what it's called. And in this for each loop here with all these strings, we're going to be adding every single thing. And this will just take in the string from the for each loop. And then what it'll do is we'll take this map, we'll find from it that same string from the for each loop, and we'll put that in as the value that we pass into the map. Well, we do that for like this for each loop inside of this for each loop. And at the very end of it, it's going to have a full map of all the sub-objectives with their completion percentage. So that now allows us to finally go back into our quest component where we left off. After we find in our active quests the object, we can finally now get the completed objective progress, which gets us 1 pin of quest data. And let's make sure that we have that finished up as a function. Oh, we actually don't. Good thing we checked it. So for the output, we'll make it. And we'll make it with the quest ID and the output map from this getCompletedObjectives function. And then finally, back in the quest components, now that we have checked that everything is implemented properly, we add a return node here so that we can add an output, which is going to be our active quests. And that's going to, of course, have a value of quest save data. And it's going to be an array, which will populate on the completion of the for each loop. I will promote it to a local variable. We'll call it quest data. And inside of the for each loop, every time we go through, we just add to it whatever output comes out of this quest base. With that, we can come one step back out again into the quest game instance. And there we can finally use our quest component input parameter for the update quest data to get the active quest data as an array out of there. Now, we just set up everything to provide its data, so that is a huge part of this system done. Now we just need to add that to this object, which is not entirely super straightforward, but it is going to be okay. At least we don't have to jump from class to class as much for this one. So for this one, we're going to go into the quest save and make a function in there. And we'll call this something like add to active quests. That's going to take in an array of quest data, of course, because that is the entire reason why we just jumped around so many classes and fixed up some things there, to get all that data into a single array to pass into this function. So let's call this new quest data. And it's going to be quest save data. It's going to be an array. And we're going to for each loop over that array. And this is actually everything we need to do in this function, because we're just going to run an entirely different function on each element of this for each loop. So let's make that new function, and we can call this something like single quest data. This is not really meant to be used in an individual basis from like outside from any other objects or whatever. So what we're going to do is we're going to go here into the access specifier and set it to either protected or private. If you plan to make child objects of this, this might be relevant to be able to access in child objects. For the most part, I think you should mark this as private. You don't want to get confused and accidentally call this on something or whatever. This is only going to be called from to active quests. And of course, this is then also going to have the same input. So let's call this new quest data as well. And that, of course, has to be a singular variable instead of an array. Now, this is going to be a slightly tricky one. So what we're going to do is inside here, we're going to take our active quests variable that we have on our save object, and we're going to for each loop over this. Now, I do need to warn you that what we're doing is we're for each looping over the data that we're getting given in. And then for each one of those loops, we're doing an entire loop over everything that is in our save object. That's going to add up quite quickly because, spoilers, there's going to be another for each loop at the end of this as well. So we're going to do very quickly going from tens to hundreds to thousands of operations within a single game tick here. So don't call this during gameplay. This is a thing that you call at the beginning or the end of loading a level, or when you specifically need to update your quest save data because you're like saving it to slots and you need to make sure that you have the most up-to-date information. This is not the type of function that you call every single time you gain a new quest, because every single time you gain a new quest, beyond a certain point, you're gonna really experience a momentary frame dip because of it. It's gonna do quite a number on your CPU when these lists get quite long. Now, that said, let's split this structure pin because we don't actually need it as a full structure pin. And the first thing that we're gonna do is we're gonna put in a branching node. And we want to check whether this quest ID from this for each loop that we have is exactly equal. So that is 3 equal signs, not just 2, but 3, to the quest ID that we get out of the input parameter here. So we want to check that. Because if we are checking against a quest that has the exact same ID, we're checking against the same quest, which means that we have found the quest that we want to update in our quest list. So after this, we can cancel out of this operation to save ourselves looping over things that won't be relevant anyway. So if we find that, we can get the keys from this map up here, and then we can for each loop over every single one of those. So this is the last for each loop we're going to go through. And here we need to do something a little iffy, and that is we get our active quests from this variable array, and we need to get a reference. Do not get a copy, get a reference, because we're going to be actively updating the data inside here. If we get a copy, it doesn't actually update the data inside the array. Copies are good for reading, they're quick. References are for when you actually need to change the actual data in the array itself. So that's why we're getting a reference, and then we break that reference open as well, because we're going to need to get the progress here, and we're going to be adding some stuff to it. The great upside about a map is that it doesn't allow you to add the same key twice. If you try to add something that's already there, it's just going to overwrite the corresponding value, in our case a float, with the new value that you're giving in. So we're just going to be adding the objective ID, which is what this is in here, and then we need to give it a value. And this is kind of where we get to a little bit of a question as to how sophisticated you want and need this to be. Because if you are in a level and you leave it and you go into a different level, you probably won't have to worry at all about overriding this progress. Because the objective isn't going to exist in that other level. So when we try to write our objectives to this thing, in theory, it should leave any objective that doesn't exist in the level that you're currently in alone. It shouldn't overwrite that. That said, there are edge cases where this might be relevant, and that might actually end up happening. Specifically, if you have a quest ID with also an objective ID that is shared between 2 different levels, that might be relevant, especially if you're doing gathering quests that are valid in a couple of different levels, that you want to be accumulatory in their progress. This kind of thing will pop up. So just to be sure that that is all dealt with and okay, what we're going to do is we're going to get this map reference over here, and then we're going to use a find. And then we're also going to use a find this map reference that we have over here. And we're going to be finding the exact same value. And it's a little cheesy, but we're just going to get the max value between the two of them. Because in what game ever does your quest progress go backward? If you're making specifically a game in which your quest progress can go backward in some cases, and this is not just for a quest as a whole, this is for specifically each objective to itself, you're very unlikely to make something where you can gather some stuff and then suddenly have less progress than you did before, right? Progress in a quest, in an objective, usually only moves forward. So just getting the maximum value between what you have saved and what you have in memory currently should make sure that it doesn't get overwritten due to any weird stuff, due to proxy quest actors or whatever. So that is the reason that we do that. Now, if we have done this and we've gone through this entire for each loop, and that means that we have found a exact match for our actor, we can just return to save ourselves going through the rest of this for each loop, and more importantly, through the rest of this for each loop. However, if we reach the end of this first for each loop without ever getting to the quest that we're checking for, that means that we just don't have information on that quest in our save list yet. So in that case, we can just get our active quests and we can add unique. Very likely, you can also just use add instead of add unique. It probably will be fine. I like just doing add unique, and we'll just add the input data from that. So now it will add it to the list because clearly we don't have anything to update. We just need to add some new stuff. Then going back into add to active quests, making sure that these two things are hooked up. That is the next little bit done. So we can fairly easily now of our save object to active quests. This array goes into that array, and now this event is done as well. It was quite a little bit of a headache, but it is finished now. Which leaves us with only one more event to make in the game instance, and that will be a custom event again, and we'll call that get quest data. And this one is quite long as well, but it's fairly straightforward. So what we're going to do first and foremost is get all actors of a specific class. And the actors that we're going to be getting will be anything that is a base quest. Now, anybody familiar with the actors of all class node knows that this is also fairly expensive to run. So this is another one of those things. This is going to run one time at begin play, and then you're going to leave it alone because you don't want to be doing this constantly. Let's do a for each loop over that array though. And here we just get our quest save data. And from there, we get our completed quests. And since we're iterating over the individual quests, we can just get the ID from each one of them and check whether or not it is contained within the completed quests. Because if it is, we don't need to do anything too complicated. We just know, hey, this quest is completed. We can just add it to our completed list and just leave it alone. So let's do that. We add in a branching node for that logic. We do technically want to start the quest so that it initiates all the objectives. That way you can still see the objectives in your finished quest list view, but it's not going to like give you the rewards again or anything. And then we want to, much like before, use a quest component input here. So let's make this, it still is on quest component. That's fantastic. Quest components. And we just use that to get the finished quests and add to that the name of the quest ID from our current iteration of the for each loop, together with the object from that for each loop iteration. And we just hook that up like this. That is dealing with finished quests. Now let's deal with quests that have been started but not yet finished, because as the theme is with this video, that is where the headaches come in. Kind of. We've had the worst headaches behind us. Let's make a copy here of the save quest reference, and we get the active quests, for which we're going to nobody's surprise, for each loop, and we'll hook that up to the full spin of this condition. Here, we're going to check with a break if the quest ID that we have here is equal to any, again, exactly equal with 3 equal signs, to any of the quest IDs that we have in our active quest list. Because if so, that is where we actually activate and add the quest to our quest component. So if that is true, we get our quest component reference again, which is going to be very noodly all over the place, but I like that. And we add a quest, and the quest that we'll add will be the element from this for each loop. And we hook that up to the true side of that branch. Now, we've added the quest to our in-progress quests. Now we need to go back into the base quest real quick to add in a new function, because we made this get completion objective progress, but we also need one to set it now. But that's going to be so much easier, because what we can just do is we can just set completion objective progress, and we just get our objectives, which already I think has a set objective complete by ID, which is still entirely based on arrays again. So we need to go into there, and instead of using this with an array, we're going to be changing this to a map with float values. And for the basic one, it's actually relatively simple. We get rid of all this. We just find the objective ID in the map that we deliver in. We first check whether or not that find was successful to begin with, just as a little bit of a security check. And then we check whether or not the completion progress is greater than or equal to 1. And then we just set our is complete to the output of that. We're not doing the on completion finish objective function here, because that calls out this delegate, and it can be a little bit bothersome because you might have things listening out for it that like update things, and it might accidentally finish parts of the quest that might have rewards tied to them or whatever. If you are building this out in a more complex and complete way, that can be annoying. So in this case, we're actually just going to set this value directly. Oh yeah, and then we want to make sure that we're comparing this to be greater than or equal to 1, not 0, because otherwise it's always going to be true. Then, as always, we need to go into the objective collection and overwrite the version that that has as well. So we can set objective complete by ID. And this one is slightly more complicated, but not by that much. So let's do this. What we're going to do is we get the sub-objectives, and we'll for each loop over those. And for all of these, we're going to just kind of call the same function. So we set objectives complete by ID, and we just forward in the map that we're getting given in here. Do make sure to hook these two up, otherwise it's going to try to call this function within this function on this object itself, and that creates an infinite loop. So make sure that this node is hooked up to the for each loop. Then for each one of these, we also get the completion progress, which gets us those two floats that we can use. In this one, we only really care about the clamped version. We don't really care about the unclamped version of anything. So what we do is we just make a quick local variable, total progress, and we just set that to being total progress plus the unclamped completion rate for each iteration in this loop. And then on completed, we just set is complete in much the same way that we did before, directly hard-coded, not through a function that has like a delegate to it, because we don't want to do that. And we get this total progress, simply divide that by the length of our sub-objectives array to normalize it to a 0 to 1 range. And then we just check whether or not that is greater or equal to 1 to set our is complete state. So now back in the base quest, we have this set completion objective progress, which is going to just take in this map. So most of these functions are just taking in the map and forwarding them to an object that actually knows how to deal with them. That is mostly what is going on here. So in the quest game instance now, what we can do is we can use the array element from this for each loop in the quest data event. And we can use it to set completion objective progress. And we do that by providing in the broken data from our getActiveQuests thing here into there. Now that's all the system code in place for allowing us to update and get the information and save and load it to save slots. Now we just need to make a quick actor that allows us to go between levels and add a little bit of extra code to our quest component to actually make this work. But saving and loading itself already works. We can just make a menu, and every time we want to load the data, we can load it from disk, and when we want to save the data, we first update the quest data and then save it to slot. So, matter of fact, if you're going to save quest data, you probably want to just update quest data first and provide in that quest component as a reference as well. So all of this will now work. So let's just, for demonstrational purposes, so let's make that extra actor real quick to show you going between levels. I'm just going to do this properly right away. Level loading zone or something like that. Let's do a box collider. Can set that to being like somewhat larger. And then on begin overlap, we just cast to third person character to check whether or not the thing overlapping is a third person character, hence a player. And then we also get the game instance, which we cast to our quest game instance, from which we can just call update quest data, which needs to be given in a quest component. But hey, we already have a reference to our third person character, so we can just get our quest component from that and provide it in there. After we do that, we can just open level by object reference. Why not? We can just promote that to a variable as well. I don't know if that works in Blueprint, to be 100% honest, but I think it should. And then in our quest component, we go back into the event graph in begin play. We already make a quick little widget here. But in this now, we get the game instance as well, which we of course cast to our quest game instance, which we then use to get the quest data, which requires in a quest component, but we're in the quest component, so we can just provide a reference to ourselves, make sure everything is hooked up with the execution pins. I always forget that. And after we get the quest data, we're just going to hard refresh the quest UI, because we have gone out of our way to not call any event dispatches or any of that kind of stuff while reloading a bunch of data, because that can slow things down and maybe be unwanted in a lot of cases because it can trigger weirdness. So we've been avoiding that. We're just going to update the quest list just explicitly here. Also helps that it's not running the update quest list 1,000 times within one frame, because we are avoiding all those event dispatches in the code that we just wrote. So that's another reason to avoid that. So that effectively should allow me to move between two different levels now. So let's real quick make a second level to test this in, because I don't think I have one. Yeah, I don't. So I think that's in File, New Level. Let's just do a basic level. And in here, so if we take in, for instance, our kill quest, which actually I don't think I gave a quest ID, which is quite important. So let's go quest ID. Yeah, let's give it killing as a default value, and then just plug that right in here. You'll see that it has target 1 and target 2, which aren't filled in. We're going to see if that's a problem in a moment, because I don't know if it will be. Let's go into the level blueprint, where we just make a reference to it real quick, and then we make a trigger box around it. That's going to be like relatively large, something like this. Then we add an event trigger for that, overlap. Other actor we cast to third-person character. You know the gist by now. We get the quest components and we add this quest. So the wonderful thing is we'll be able to add this quest now in here, but we won't complete it in here. Now, we'll complete it in the other level, obviously. So after we pick that up, let's do our level loading zone, which is right over here. And that's going to load the third-person map. And now see, I can run in here and I get my quest, but it's not bound to anything actually like in here. If I put some items in here, it will work, of course. Those aren't really bound to specific items. Those are just bound to stuff that happens in my inventory. But the enemy killing, for instance, the objects just don't exist here, so I can't complete them here. But if I keep on moving to my loading zone over here, you'll see that I don't need to pick up the quest here to actually have it unlocked already, because it carried over the fact that my quest is unlocked from the other map. Now, if I kill one of these things, you'll see that it completes it here. It has the next thing already completed as well. Let's pick up a couple of the items that we have over here. And now I actually don't have a way to go back to the other level. Hold on. I will be back in a moment. Just going to put down a level loading zone in here that links back to the untitled level, which actually allows me to show that it works the other way around as well. So I can pick up my second quest here and I can kill one of these, which spawns the other one in over there. And I can pick up like some of the items from this quest. And then when I move over to this loading zone, it still has all that progress saved within here. It doesn't quite yet for these, because we haven't implemented that logic yet, but we'll do that in a moment. And then when I go through again, I can't pick up the quest a second time, just like always. It will still have all that progress. Now, it doesn't quite like trigger all the code for setting up the next activation quite perfectly. And that is because we are skipping over all the finish objective event dispatches. So just using finish objective here, if this is greater than or equal to 1, is an easier way to get around that issue. If it creates other issues though, you might need to create some code that explicitly activates the first objective that's next up in the list. Kind of depends on what issues you run into at this point, honestly. For now though, instead of doing this direct setting for is complete, I think just doing finish objective. It's not ideal because again, it's also going to be updating the UI like very rapidly a lot. So I would personally try to avoid this, but maybe that can be a video in the future. Because now you will see I can kill this one, and then when I next get back, this one still exists, but it already also spawned in that one. Am I talking out of my ass? So at this point, it's a little like patching up of issues here and there, of course. So we can go into the specific killing objective that we set up at some point. And here we can also make sure that when we finish the objective, we get the enemy ref. We check if it is valid, just to be sure. Because if it has already been destroyed, we don't want to destroy it again. But if it is not yet destroyed, we can just like explicitly destroy it like this. And that way, when we come back, it will automatically instantly destroy any of the objectives that have already been finished off for any killing quests. You need to do this for every single objective type that it is relevant to, of course. But you only need to set it up once, and then you can use the objective over and over and over again. So you can see no sphere over there, but it is still over there. Now, the last thing, and also you maybe want to add in an is valid on this one as well. For anything that you potentially like destroy and then read, putting an is valid in between is good. The last thing is setting and maintaining the progress on the item completion quests. So let's go into our item gathering objective. And the main thing here is just to override the function for set objective complete by ID. Because what we're going to do here, we can just do the parent function as well if we want to, because this just takes care of setting it to being either completed or uncompleted. But what we want to do in this one is we then also want to set our information based on this. So we find our ID, so get objective ID. And then what we do is we just set the amount gathered to the amount to get, multiplied by this completion percentage that we're given in. And that should always return an integer anyway. And that should take care of all of that. So let's pick up the quests and let's pick up some of these items for a little bit of progress. Not all of them, because I want to specifically keep track of whether or not it keeps track of partially completed objectives, and now it does. So when we go back, we can keep on going with completing this quest where we left off. And the wonderful thing is, at this point, if we go back into the untitled map, we can add in a couple of item pickups along the way here. And since we're not binding to any specific items to pick up, what we can do is we can set this up to be like item 1 and have a couple of them in here. We can start a quest and actually gain a little bit of progress in this map. And that progress will carry over, and then we can gain a little bit of progress over in this map. Then we can go back to the other map again, and the progress will carry over. And we can even straight up like finish that part of the quest in this part right here. And then we can go over to right here, where we see, hey, get grass is finished. So completion of quests also now carries over, which means that we effectively have everything that we need for an entire full quest system. If you want the finished projects, as always, there's a link down below in the description for YouTube members and patrons to get the finished projects, mostly intended for educational purposes. But hey, if you just want to like pick it and put it in your own project, that's fine too. And that, of course, also massively supports me and the channel in making more of this type of content. So thank you everybody for watching, and those of you who are directly supporting me, thank you doubly so. And I will be back next time with some newly invented stuff. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Digger tier supporters, Sir J. Thomas,